Hey everyone, and welcome back to the Deep Dive. Don't forget to hit that like button, subscribe to the channel, and click the bell icon to stay updated on all our future deep dives. Today, we're tackling a topic that's both mysterious and crucial for anyone interested in space, especially those preparing for the UPSC or just diving into the wonders of our solar system. We're talking about minor planets. Think of it this way. If planets are the main characters in our solar system story, minor planets are those fascinating supporting characters who add depth and intrigue to the whole narrative. They might be smaller, but they hold incredible clues about the solar system's past, and even potential implications for our future. To help us unravel this cosmic tapestry, we're joined by our expert in astronomy and planetary science. Welcome to the show.
It's great to be here, ready to explore the fascinating world of minor planets.
Absolutely. Let's dive right in. I think for many of us, the term minor planet might sound a bit vague. It's like, are they planets? Are they not?
Yeah.
Could you help us clear that up? What exactly are we talking about when we say minor planet?
You've hit the nail on the head. The term itself can be a bit confusing. Essentially, minor planets are celestial objects that orbit the sun, just like the major planets we know and love, but they're significantly smaller. They're bigger than meteoroids, those tiny specks of space dust. But they haven't cleared their orbital path in the same way that larger planets have. Think of them as the solar system's leftovers, remnants from the very beginning holding secrets about how everything came to be.
So like cosmic breadcrumbs leading us back to the formation of the solar system. That's pretty cool. You mentioned they're leftovers. What are they made of exactly?
Good question. Most minor planets are composed primarily of rock and metal, sort of like the Earth's core, but without all the layers we have on top. These materials clumped together billions of years ago during the solar system's formation, but never quite reached the size needed to become full-fledged planets.
Okay, starting to get a clearer picture now. Now, when I think about minor planets, the first thing that pops into my head is the asteroid belt. Is that where most of these objects are hanging out?
You're exactly right. The asteroid belt is like the main street for minor planets, especially asteroids. It's a vast region located between Mars and Jupiter, filled with millions, maybe even billions of these rocky and metallic bodies, all orbiting the sun.
Millions. Wow, that's a lot of cosmic traffic. I imagine it must be a pretty chaotic environment out there.
It can be. The asteroid belt isn't just a calm, orderly procession of objects. Jupiter, with its massive gravitational pull, plays a huge role in shaping the dynamics of the asteroid belt. Its gravity prevents these asteroids from coalescing into a planet, and instead creates a sort of cosmic dance, with asteroids constantly bumping into each other, changing trajectories, and even getting flung out of the belt altogether.
So Jupiter's like the cosmic choreographer of the asteroid belt. It's amazing how one planet's gravity can have such a huge influence on this whole region of space.
Exactly, and it highlights the interconnectedness of everything in our solar system. Now, within the asteroid belt itself, we have a wide range of sizes. Some asteroids are as small as pebbles, while others are significantly larger. In fact, the largest object in the asteroid belt series is so large that it's actually classified as a dwarf planet.
What a dwarf planet, so there are different types of minor planets. I'm guessing the classification depends on their size.
You're catching on quickly. Size is one of the key factors in classifying minor planets. Ceres, with a diameter of about 950 kilometers, is so large that it's gravitationally rounded, meaning its own gravity has pulled it into a spherical shape. That, along with its orbit around the sun, earned it the dwarf planet designation.
So Ceres is like the VIP of the asteroid belt. It's the one that got its act together and achieved roundness. What about those asteroids that get a little too close to Earth, the ones we sometimes hear about in the news?
Those are the near-Earth asteroids, and they're definitely the ones that keep astronomers on their toes. Their orbits bring them relatively close to Earth's path, and while the vast majority pose no immediate threat, it's crucial to track their movements and understand their potential impact.
That makes sense. It's like having a cosmic early warning system to make sure we're prepared for any unexpected visitors. So we've talked about asteroids in the asteroid belt, but I know there are other types of minor planets out there. Where do we go from here? What other fascinating objects are waiting to be explored?
Well, let's take a giant leap outward, past the orbit of Neptune to the realm of the Kuiper belt.
The Kuiper belt. That sounds like something straight out of a science fiction novel. What exactly is going on out there?
Imagine a region of space so vast and cold that it's like a cosmic deep freeze, preserving remnants from the solar system's earliest days. That's the Kuiper belt. It's a donut-shaped region filled with icy objects, including comets, dwarf planets, and countless smaller bodies. It's like the asteroid belt's distant frosty cousin.
So while the asteroid belt is rocking out with its rocky and metallic crew, the Kuiper belt is chilling out with its icy posse.
Pretty much. The composition of these objects tells us a lot about the conditions in the early solar system. The ice in these objects contains trapped gases and other volatile compounds that would have evaporated closer to the sun. By studying these icy bodies, we get a glimpse into the ingredients that were present when the planets were forming.
That's amazing. It's like having a time capsule that's been frozen in space for billions of years.
Yeah.
Now, you mentioned dwarf planets in the Kuiper belt. Of course, the most famous one is Pluto, which went through a bit of an identity crisis a few years back. What's the story there?
Pluto's demotion from planet to dwarf planet caused quite a stir, but it actually helped us understand the solar system better. You see, the Kuiper belt is home to many icy bodies, and some of them, like Pluto, are quite large. Astronomers realized that if Pluto was a planet, then many other similarly sized objects in the Kuiper belt would also have to be classified as planets. This led to a redefinition of what constitutes a planet. And Pluto, along with other large Kuiper belt objects like Eris, Haumea, and Makemake, now falls under the category of dwarf planet.
So Pluto's demotion wasn't a punishment, but rather a recognition that the solar system is far more complex than we initially thought. It's like realizing that your family tree has a whole bunch of distant relatives you never knew about.
Exactly. And speaking of complexity, let's touch upon another fascinating aspect of our solar system, Lagrange points. These are special locations in space where the gravitational forces of two large bodies, like the sun and a planet, create a sort of balance point.
Lagrange points. That sounds intriguing. Is this where those Trojan asteroids we talked about earlier hang out?
You got it. Trojan asteroids are a great example of objects occupying Lagrange points. Specifically, they share Jupiter's orbit, clustered around two of its Lagrange points. Imagine these points as cosmic parking spots where the gravitational forces from the Sun and Jupiter create a stable zone for these asteroids to hang out.
So Jupiter's like a cosmic shepherd, keeping its flock of Trojan asteroids in line.
That's a great analogy. And Lagrange points aren't just home to asteroids. They have practical applications in space exploration, too. For example, the James Webb Space Telescope. One of the most powerful telescopes ever built is positioned at a Lagrange point, allowing it to maintain a stable orbit and observe the universe with incredible clarity.
Wow. So these Lagrange points are not just theoretical curiosities. They're actually being used to help us explore the universe in incredible ways. It's like finding a cosmic shortcut that allows us to get a clearer view of the cosmos.
You know, it's amazing to think about the sheer diversity of minor planets out there. They're not just chunks of rock and ice. They're remnants from the early solar system offering valuable clues about how planets form. Absolutely. It's like having a cosmic history book right in our own backyard. By studying these minor planets, we can learn about the conditions that existed billions of years ago, the processes that led to the formation of our solar system, and even the building blocks of life itself.
It really highlights how much there still is to learn about our own cosmic neighborhood. Now, we've talked about different types of minor planets based on their location, but what about their size and composition? Are there any notable examples that stand out?
Definitely. We've already mentioned Ceres, the largest asteroid, which is so big it's earned dwarf planet status. But even among the smaller asteroids, there's a huge variety. Some are almost entirely metallic, like remnants of ancient planetary cores, while others are rich in carbon, the very element that forms the backbone of life as we know it. And in the Kuiper belt, we see objects with surfaces coated in reddish organic compounds, hinting at even more complex chemistry at play.
Wow, that's incredible. So these minor planets aren't just fascinating objects in their own right. They're also windows into the past and potentially the future of our solar system. From tiny metallic asteroids to vast icy worlds in the Kuiper belt, it's clear that there's a whole universe of discovery waiting for us out there. Welcome back to the deep dive. I don't know about you, but I'm already feeling like I've gained a whole new perspective on our solar system.
It's been quite a journey, hasn't it? And the most exciting part is that we're still just scratching the surface of what we can learn from these fascinating objects.
Exactly. We've talked about what they are, where they are, what they're made of. But how are we actually getting this information? I mean, these objects are incredibly far away. How do we even study them?
That's where human ingenuity and our thirst for knowledge come in. Over the past few decades, space agencies around the world have developed incredibly sophisticated tools and techniques to study minor planets. We're talking about telescopes that can peer into the depths of space, spacecraft that can travel billions of kilometers, and instruments that can analyze the composition of celestial objects from afar.
It's like we've become cosmic detectives, piecing together clues from across the vastness of space. So what are some of the key methods we're using to unlock the secrets of these minor planets?
Well, one of the most fundamental ways is through observation using powerful telescopes. Both ground-based telescopes here on Earth and space telescopes like Hubble and James Webb allow us to study the light reflected from these objects. By analyzing the spectra of this light, we can determine their composition temperature and even their rotational speed.
So just by looking at the light from these objects, we can learn a surprising amount about them. It's like having a cosmic fingerprint scanner.
Yeah.
But I imagine that to get a truly up-close and personal view, we need to send spacecraft out there.
You're absolutely right. Space missions have revolutionized our understanding of minor planets. One common type of mission is a flyby, where a spacecraft travels past an object snapping high-resolution images and collecting data as it goes. These missions have provided us with incredible views of asteroids and comets, revealing their shapes, surface features, and even the presence of moons or rings.
That's like a cosmic drive-by. But instead of causing trouble, we're gathering valuable knowledge. But flybys are just a quick glimpse, right? What about missions that really linger and give us a deeper understanding?
That's where orbiters come in. These missions involve placing a spacecraft into orbit around a minor planet, allowing for long-term study and detailed mapping. The Dawn mission, for example, orbited both Vesta and Ceres, giving us unprecedented views of these two very different worlds in the asteroid belt. We learned about their geological history, their composition, and even the possibility of past or present water ice lurking beneath their surfaces.
It's like setting up a research station in space, right there on the surface of an asteroid or a comet. Very incredible. But we're not just looking at these objects from afar, are we? I've heard about missions that actually bring pieces of these minor planets back to Earth.
Yes. Sample return missions are the ultimate prize in planetary exploration. The Hayabusa 2 mission, for example, returned samples from the asteroid Ryugu, giving scientists a chance to study pristine material from the early solar system in laboratories here on Earth. And the OSIRIS-REx mission is currently on its way back with samples from the asteroid Bennu. These samples are like time capsules, holding clues to the origins of our solar system and perhaps even the building blocks of life itself.
It's mind-boggling to think that we can actually hold a piece of an asteroid in our hands, something that's been drifting through space for billions of years. It really underscores how far we've come in our ability to explore and understand the universe around us.
Absolutely. And the future of minor planet research is even more exciting. New telescopes are coming online, and even more ambitious missions are being planned, including missions to potentially mine resources from asteroids and to explore the icy depths of the Kuiper belt in even greater detail.
So there's a whole universe of discovery still ahead of us. And to all our listeners out there, especially those preparing for the UPSC or just starting your journey of exploring the cosmos, we hope this deep dive has shown you that minor planets are anything but minor. They're a vital part of our solar system story, holding clues to our past, present, and future.
Keep looking up, stay curious. And who knows, maybe one of you will be the one to make the next groundbreaking discovery about these fascinating objects.
That's a great note to end on. And as always, thanks to everyone for joining us on the deep dive. Don't forget to like, subscribe, and click the bell icon to stay updated on all our future explorations. Until next time, keep exploring.